Before we begin, does anybody want to ask about any of the questions from the quiz? You okay there? How did Gabby do on Wednesday? Do you have a nice list of how to compare fractions, different methods? What have you got? We won't number them because there's no order, but what's a method that if I give you two fractions and ask you which one's the biggest, what can you do?
You could turn them both into decimals by dividing the denominator into the numerator.
Turn. Okay, well, this is, we'll call it comparing fractions. Turn into decimals. How does that help?
Because you can see what's like greater in like the tens place and the
Then you can
hundreds
compare it by
place.
place value. A little bit easier than by comparing the fraction themselves, okay? Turn into decimals and compare corresponding place values. By corresponding, I'm talking about, you look at the tenths place for the one and the tenths place for the other. Those are corresponding. And you do that, if they're the same in the tenths, then you keep moving to the right, correct? Okay? What other methods do you have of comparing two fractions? Yeah?
You can make the fractions with the same denominator.
Okay. Make equivalent fractions with common denominators. And now that you've got those, then what do? Compare the numerators. And which one is going to be the biggest fraction? One with the bigger number. Why? Because if I have 17ths of both, or 25ths of both, or whatever, in other words, if the two pies are cut into the same number of pieces, the one with the most number of pieces that we're considering is the biggest, right? Does that make sense? Talking about? Okay. What else?
Make equivalent fractions with common numerator.
Make equivalent fractions with common numerators. How does that allow you to do it?
Then you check the bottom. And
Check the bottom.
whichever one's the smallest.
Why?
Because there's more.
If I have four let's do this. 14 27ths and 14 28ths. Which of those fractions is the biggest? If this pie is cut into 27 pieces and this into 28, which pieces are the biggest? 27ths, right? The fewer the pieces, the bigger the piece, right? If we've got a whole pie. And now I've got 14 of the bigger pieces compared to 14 of the smaller pieces, making this the bigger number. Does that make sense? Okay. What else? I'm hoping somebody used, sometimes this is the very easiest.
You can cross multiply.
Throw that one out. No. Every book teaches that. But it's kind of a trick. And unless you understand what's going on, does everybody know what she's talking about?
Cross multiple?
Yeah.
You know how you do that with the equals sign? Like if you're looking for an x and you have an equals sign?
Well, that's one time you can.
Yeah, you can compare. Oh, compare the sizes? Because that would
Can you show that?
Yeah, I don't
Yeah.
know.
Let's just take 2/3 and 3/4. Should be obvious to all of you which one's the biggest, but when we cross multiply, this is what they teach you to do. They go this times this, which is 8, and write it above this one. And then this times this is 9, right? And then whichever one the smallest number is above, that's the smallest fraction. Whichever the biggest number is above, that's the biggest fraction. Right? Did she teach you that one? She wasn't supposed to.
No.
But this is probably the way most 5th and 6th grade books teach it. But what is going on?
That's what you do essentially when you're trying to find that common denominator.
Yes.
You're just only doing the top part though.
I'm doing 4 times 2 and putting 8, but 4 times 3 is 12, so I really have 8 twelfths.
Yeah.
And then I'm doing 3 times 3, but I need to do 3 times 4 and get 9 twelfths. So I've got a common denominator now, and naturally the one with the biggest numerator. That's what it is. It's a trick. There's no understanding behind it unless you see that it is tied to the... So over here I'm going to put cross multiply, and then I'm going to cross it out saying don't teach it. It's just another thing for them to cram into their heads with nothing about what makes sense about it. It is a method. And it is based on this. So why not teach this? Because this makes sense. If they know what fractions are. Oh, 8 twelfths or 9 twelfths? I can tell you which one's the most. Cut a pie into 12 pieces. You want to give me 8 of the pieces or 9? Well, 9. It's the right kind of pie, huh? Anyway. Okay? What else?
Can you do a number line? Is that just for this?
How's that going to help? So if I say 2/3 and 3/4 and you put them on the number line, you say, well, there's 0, there's 1, and 3/4 is about right there, and 2/3 is about there too, isn't it? In order to do a number line and be able to make the comparisons, you need to do what? Get a common denominator. So I'm going to cut this into fourths, right? So that would be the 3/4. And then I'm going to cut it into thirds, right? There's 2/3, which means I'm really going to cut it into twelfths, right? So, let's see. That would be 1, 2, 3 twelfths. A third is 4 twelfths, right? Then 5, 6 twelfths, 7, 8 twelfths. And there's 9 twelfths. And wait a second. 1, 2, 3, 4, 5, 6. There's a half. 1, 2, 3. Let's see. 6, 7, 8, 9, 10, 11 twelfths, right? And this one would be our 3/4, and that would be our 2/3. You almost have to have those common denominator twelfths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 twelfths. 8 twelfths and 9 twelfths in order to do that. So we could write down here, number line could be helpful, but it would be in conjunction with that, I think, yeah.
I don't think it would work every time, depending on how big your fraction is, but you could draw pictures. Like, if you have like 2/3, 1/2, 3/4, like, for the more simple fractions, you could like draw like a circle or like a pie chart or whatever and
Yeah.
compare.
This might work for this one. 2/3, right? And then we color in 3/4 and we color in 2/3, and you're saying, I can tell by looking at this which
Yeah.
is the biggest.
But it won't, obviously, it won't work for like big fractions.
And for some that are very, very close to each other, by
Yeah.
looking at them, you wouldn't be able to tell. Now, if you had models of really accurate ones, you could put them on top of each other and see if they were accurate. But kids just drawing them, sometimes they could draw 3/4 that look smaller than 2/3 if they did it incorrectly. So I think that is helpful. Use models, and I'll put included on that drawings, but sometimes that may not be too helpful. But it is a method, and I think you should use it with students, particularly if you've got some little plastic models of rectangles or circles or something like that. Let them compare it that way.
Would you use it as kind of a backup for another method?
Yeah,
Like a visual representation of what you're talking about?
you already know that we want to teach
Different learning styles.
different methods for different kids to, sometimes the more methods, the better they understand it. Anybody else have a, if I give you 2/3 and 3/4, you shouldn't have to do any of these up there. You should just be able to look at them and think. What would you be thinking?
For like small ones like that, well, I always think of as like measuring cups. Like, does that make any sense?
Okay.
So like,
And
I
if
think
you've
of
cooked a
actual-
lot, you know that this one is smaller than that one. Okay.
But like obviously you can't do that with bigger fractions.
Yeah.
Unless you like reduce them down.
Okay. Well, let me illustrate it with something that's, I don't know what you mean by bigger fractions, but let's try this one here. Which is the biggest of these two? You better know, and you better know pretty quick. How? Somebody want to explain it? Try it.
I don't know if this is what you're looking for, but sometimes for me it's easier to figure out what's, trying to figure out how to explain this right. Figure out what's left over from the whole. Is that like with 2/3 and 3/3? It's
Or
easier.
3/4, you mean?
Yeah, it's easier for me to say, okay, well, even without drawing out the thing, it's easier, although it kind of relates to that, to say, well, which one's bigger, 1/3 or 1/4?
The part that's missing from the whole.
Yeah, and so with that one, you could
And
say.
a third is bigger than a fourth, so it's missing more, so it must be smaller.
Yeah.
Is that what you're saying?
Uh-huh.
Same thing here, right?
Yeah.
Both of these are very close to the number 1, right? But this is 1/18 away, and this is 1/19 away. Well, which is bigger, an 18th or a 19th? An 18th is bigger, right? So this one must be closer to a whole, meaning it's bigger. Does everybody follow? We're not using any of these decimals, common denominators, we're just thinking about the meaning of the fraction. And okay, so I really think that you ought to look at this here and and go I'm going to call it number sense. And I think, in fact, I'm going to put a star by it because I think it's one of the most powerful things that you need to teach your students. If I were to give, let's go 2/3, 5/11, and 27/54. Number sense is the way to go. Why? Put those in order from least to greatest. Shouldn't need a calculator. Who can do it?
It would be 5/11, 27.
Because?
Because 5 is less than 6, which is less than half. Or 5 is less than 5.5, which is less than half.
So half of 11 is 5.5. So this is less than a half. This number is less than a half. Do everybody see how she thought it through? Okay, keep going.
And then 27 is half of the 54.
It's exactly half.
And then 2/3 is more than half. So it's the greatest.
Yeah, half of 3 is 1.5, and that's more than that. So this is numbers more than a half. If your students can't tell whether a fraction's more than a half, less than a half, or equal to a half, then you haven't taught them right. And if there are 3 numbers and one's less than a half and one's equal to a half and one's more than a half, it's pretty obvious what order to put them in, right? Don't bother with any of the procedures or algorithms or cross multiplication or anything else. Just think. That's the best way to go. And sometimes that alone is all it takes. Sometimes they'll all be a little above a half, and you'll have to say, well, which one's the most above a half? And that could be another question you could ask. Okay? Case in point, let's just do it. 4/7, and how about 5/9? And you say half of 7 is 3.5, right? Well, I am a half of a 1/7 above that. And here I'm a half of a 9th above 4.5, right? 4.59, so a half of a 9th. Well, which is bigger, a half of a 7th or half of a 9th? Half of a 7th is bigger, so this must be the bigger number. Does that make sense? None of this decimals and stuff. You just think about the problems. Okay. That's all I wanted to say, unless you have questions about the ordering numbers. Quickly, let's do this. Get a piece of scratch paper out. Feel free to use a calculator if you'd like. And what I would like you to do is $38 in base 4, what is it in base 10?